Hi everyone, welcome to ED5963, week 6. Now this week what we're going to do is we're going to cover the term thinking in technologies, which comes from ACARA. Now thinking in technologies is one of the technologies curriculum's learning areas, and this is along with the key ideas of preferred futures and project management. Now with ACARA, there's three primary thinking in technologies areas. The first is systems thinking, then you've got design thinking, and then computational thinking. So what I'm going to do is I'm going to spend some time drawing on ACARA to talk to you about all three. So the first one, systems thinking. With systems thinking, you have to remember that a system, it's always an organized group of related objects or components that form a whole. And systems thinking is basically this holistic approach to the identification and solving of problems where the focal points are treated as components of a system and their interactions and those relationships, those interrelationships, are actually analyzed individually to see how they influence the functioning of the entire system as a whole. So with design and technologies, the first distinct but separate subject of the Australian curriculum technologies, the success of students' design solutions, it usually includes the generation of ideas and decisions that are made throughout design processes. And some of you are including these in your unit plans. And what this does is it requires students to understand systems and work with complexity, sometimes uncertainty, and also risk. And by doing this, students actually recognize the connectedness and also the interactions between people, places, and events or the environment in sometimes a local or even a wider world context. And they have to consider the impact of their own designs and actions and how they have an impact in a connected world because we're part of a system. So participating in and shaping the future of information and digital systems is a really important part of learning in digital technologies. The second subject, so understanding the complexity of systems and the interdependence of components, it's really critical to be able to create timely solutions to the different kinds of problems that young people will encounter in their lives. And implementations of digital solutions, they often have consequences for the people who use and engage with the system and may introduce unintended costs or benefits that impact the present or future society. Now we turn to design thinking. So design thinking is different because design thinking involves the use of strategies for understanding design needs and opportunities where students actually visualize and then generate creative and innovative ideas where they're planning, they're analyzing, and they're evaluating those ideas to figure out which ones will meet the best criteria for success. So design thinking actually underpins learning in design and technologies because design processes, they actually require students to identify and investigate a need or an opportunity, and here they generate and they plan some design solutions, and then they figure out and evaluate products and processes or their own solutions. And they're always considering economic, environmental, and social impacts that result from design solutions. And this is core design thinking. And that's why the kinds of questions you ask kids in the classroom are so important because it helps them tie these ideas together. So when developing solutions in digital technologies, students are going to explore, they're going to analyze, and they're going to develop ideas based on data, inputs, and human interactions. And when students design a solution to a problem that they consider, they're going to have to also consider how users will be presented with different kinds of data and the kinds of interactions with that data and the various types of computational processes that are going to be required. For example, if kids design a maze, they're writing precise and accurate sequences of instructions, to move a robot like a bee-bot through the maze, and then they're going to test the program and modify the solution. And then, with computational thinking, it's slightly different. Again, they're all problem solving, but computational thinking is a problem solving method, and that's applied to create solutions that can then be implemented using your digital technologies. And so what this does is it involves integrating strategies such as organizing data logically, breaking down problems into parts, and interpreting patterns and models and designing and implementing algorithms. And again, some of you may be doing this in your unit plans. And with computational thinking, it's used when specifying and implementing algorithmic solutions to problems or step-by-step solutions to problems in digital technologies. So for a computer to be able to process data through a series of logical and ordered steps, students must be able to take an abstract idea and break it down into defined, simple tasks that actually then produce an outcome. And this could be analyzing trends in data, responding to user input under certain preconditions, or predicting the outcome of a simulation. And so this type of thinking is used in design and technologies during different phases of design processes when computation or algorithmic thinking is needed to quantify data and then always to solve problems. So it's always about solving problems. Some examples might include calculating costs, testing materials and components, or comparing performance or modeling trends. And this could be through things, projects that students design, etc. And that's kind of a crash course in thinking and technologies in the three areas. And we're going to spend some time in week 6 covering all of this. And I just want to say, excuse me, welcome to week 6. And I really am looking forward to the different kinds of infographics that you're going to be designing to explain one of these types of thinking. And I find that when you engage in infographic design, you're having to actually think very differently about how you go about explaining something. And part of this subject is to get you to think differently about how you represent data and ideas. And so infographics is a really good way to do that. And I've shared with you a number of free infographic resources. And when you're working with young children in primary school, there's no reason why you couldn't actually get them to begin designing infographics as part of an assessment task. And you might even want to think about incorporating that into some of your unit plans. Because when kids design infographics, they're able to be more creative. And you know, kids can design infographics individually or in teams to represent something that they're doing or a problem that they're solving, because it just gives them a chance to move away from print. And we know that schools are steeped in print practices where kids are constantly writing, etc., and they're not often designing. And when we think about designing, I think about reading and writing as actually designs, because it's always about designs of meaning. You're making meaning by writing, and you're making meaning by reading, and you're certainly making meaning by designing. So I hope you do enjoy making infographics. It may be the first time any of you have ever made infographics. And so for me, infographics are something you can celebrate because they're so visual and they're so captivating. So I do really look forward to seeing your infographics and also seeing you respond to each other and your infographic designs in week 6. So thanks very much.